I can't remember. Got it. And I'll take the opportunity. I'll just wait for my clock to tick over to 7 so that we can start on time and finish on time. Thank you everyone for joining us so early. You must be very excited. Okay, we've had a few extras join us, which is great. Wonderful. Well, look, it is 7, so I'll get started. You won't be missing too much. It will just be me talking. I know you're all here to hear Gundi, not myself, but I am Steph Goldring. I am the acting CEO of Vets for Climate Action at the moment. I'm thrilled to have you all here for this masterclass in August. Just a few short housekeeping things is we've got Simone on our tech for tonight, so thank you so much for volunteering your evening. She rushed home straight from work to give us a hand, and we really value the work that our volunteers do. If I could just get you to flick through to a couple of slides, Simone, and we'll pull up hopefully you're all here for this, but yeah, I will just acknowledge a country because I believe we're all coming from different parts of Australia, and VFCA does like to acknowledge our First Nations people, the traditional custodians who have cared for the country upon which we work and meet, its land, oceans and rivers, its trees and wildlife for over 60,000 years. And I pay my respects to elders past and present and acknowledge that this land was never ceded. I think this is particularly pertinent when we're talking about the topic tonight and on climate change, because it is our First Nations people who are feeling its effect. So I extend my thanks and acknowledgement to any First Nations people who may be on this call. But I won't talk for too long because, like I said, you're not here to hear me. So what I would love to do is introduce you to Dr. Gundula Rhoades, who will be speaking on her experience. She's got over 30 years of veterinary experience, expertise, I should even say, and experience. And in 1998, Gundi moved to Australia and began raising Angus bulls with her husband. In 2002, she established her veterinary practice, Gowrie Veterinary Clinic, which is a mixed animal practice. She's very passionate, and you'll hear that tonight, about the health of people, pets and the planet, and she's converted her farm to organic practices. Her experiences as an organic farmer have allowed her to witness the remarkable healing potential of regenerative practices and their impact on the health of the soil, animals and ourselves. She passionately advocates for regenerative agriculture and sustainable living, and she's even found time to write a book called The Food Solution. So please join me in welcoming Gundi. Please pop any questions you have throughout the masterclass in the chat, and we will do our best to answer those at the Q&A at the end of Gundi's speech. So over to you. Thanks so much, Gundi.
Yeah, hi everybody. Good to see everybody. I'm really excited to, can you hear me all? Yeah, good. I'm excited to be standing here and talking to my fellow colleagues, which is just beautiful. You know, I think as a profession, I love our profession, and we are sitting in such a sweet spot of still trust. You know, like people still trust us, and Vets for Climate Action, therefore, is also, you know, a trusted organization. I think we should be really proud of that. So what made me passionate about? I just share my screen. And I just talk really freely tonight. I won't have super many slides because I find that they put people to sleep. So I just want to get the concept of regenerative agriculture across, you know, and how it can offer solutions to climate change. So that's me, you know, like, thanks for listening. So I'm a mixed animal veterinarian, born in Germany, spent a few years in England, and then came over to Australia to live with my husband on a beef cattle property. And long story short, I ended up running it by myself. So I did a lot of mistakes and I learned a lot of things. And then once all the bulls were gone, I was always passionate about the environment. I tried to convert this beef cattle property to organic, which I did. And I was not a very good farmer. I didn't have time. I had 3 kids as well and ran into sort of like practical problems. But what I did do is I learned about country and country Australia and cows and grass and soil, and then the connections about all of that. And I won't talk much about health and food tonight, but I'm passionate about that too. And funny enough, it is all one thing and all together, about how we grow food. So these were our bulls, and that's on the left is my father-in-law when he was still alive. So our bulls were really beautiful. And I came as a real sort of like, didn't have any idea about Australia nor the bush. So I had a pretty steep learning curve, and I just loved every minute of it. And then as Steph said, I started my own clinic on the farm in 2002. And that was it. And sadly, I had to sell about 2 years ago because, time, money, and the drought was just too much. But the learning stayed with me. So I did have Gauri, as it was called, certified organic, and jumped through all the hoops that you needed to do. And in the end, I had to give up the status because I, faced another drought and couldn't get my cattle feed organic anymore. However, I learned. So this is my clinic in Inverell. And, we do lots of horses, cattle, sheep, so, you're all veterinarians, it's pretty full on and pretty fun. So let's talk about soil. And I stopped sharing now here, and I've got my whiteboard behind me because I just want you to get the principle of what I'm talking about, what cattle can do, what cows can do, what regenerative agriculture is, and what it can do in face of climate change, for us. Needless to say, the drought freaked me out. That's when I met Janet, and that's when Janet founded, hello, by the way, founded Vets for Climate Action, and I was sort of part of that in the early days as well, and I'm still hanging around, but I dropped off a bit off the radar. So congratulations, what she's done is amazing. So Janet came and visited me, and we started talking really early about regenerative agriculture. And in those early days, it was just like, yeah, but agriculture has got nothing to do with climate change, does it? And I had to fight really hard, to say, no, it does, because, we have wrecked planet Earth quite badly. We have puffed 150 million tons of fossil fuels into the atmosphere, increasing our CO2, but we've also increased methane. Not the cattle, by the way, but we'll talk about that later, with nitrous oxide, which is a really strong greenhouse gas as well, and with another one that's often forgotten, and that's water vapor, all increasing, the temperature on planet Earth. So fossil fuels are, in my opinion, and I think climate scientists would agree with me, very much to blame. But of course, these other things are part of that. And climate change, we can't see in isolation either, because climate change is only part of what we have done to planet Earth, and I would put in that plastic pollution, of course, pollution of rivers, ocean dead zones, the destruction of soil, which is what regenerative agriculture is about, to regenerate the soil. And so we have just done rampage with planet Earth, and now it's coming back to bite us, not only with climate, but also with health of people and planet. So talking about climate change and agriculture has got about 40%, is 40% of the culprit in fossil fuel emissions. And that is not just through the farm trucks and the diesel, but a lot of it is actually through deforestation, of course, we just denuded so many landscapes, and that's still happening every day, but also by overgrazing, 100%. When you overgraze, you kill the soil and you kill the grasses, but also through destruction of soil. And this is exactly also where the hope is, to restore those ecosystems back to normal, to restore the water cycle, put carbon back into the ground, and to reduce nitrous oxide. So if I may just, so 40% of emissions of causing climate change is caused by agriculture. And I have always felt really uncomfortable in my little town here, which is like farmers are my clients. And when the drought was there and we had fires everywhere and, everything was dying around us, in 18 and 19, it felt really awful to talk about climate change and that CO2, climate change. It's Barnaby Joyce's electorate where I'm living. And a lot of farmers are part of the National Party. And they at the time said, oh, it's got nothing to do with carbon. And, humans are not the culprits, it's sunspots, or it's, like natural cycles, and I definitely am of the opinion that we have not treated planet Earth kindly or wisely. We've done quite a bit of damage, and I guess you would all agree. So it felt really weird in talking about agriculture being part of the problem when I'm sitting around farmers and they are my clients, and I probably was too forthright often, and said, oh, we got to do something, because the panic was really, I was really panicking, and I was also very, very sad of looking at the smoke every day and the koalas that came into the clinic every day that were dying of thirst and of dehydration. And I just thought, oh my goodness, we have done this as humans. So what I learned from that is that this is the problem that we all have to do together. It's no point in blaming anybody because it is what it is. And while I say farming is responsible to about 40% of emissions and responsible for poisoning of rivers and oceans, it is more so that we need to help each other. A lot of my farmer customers that I have really honestly do not know how to change farming so that they don't harm the environment. And cattle farming, which I will explain in a minute why it's so brilliant, is probably the least poisonous of all agriculture. And the narrative, as you all know at the moment, is that if we just become all vegetarian, if we just stop cattle producing methane, we are good, and a lot of well-meaning people become vegetarian or vegans with the real, same as I, we all want the same. We all want to save Mother Earth and the planet. But I don't think vegetarianism is the answer. And in fact, if we would actually make matters worse. So I explained the concept, how that all fits together, and why I would nearly say eat more meat, which is so completely against what the common narrative of people that are not entrenched in biology say. So if we look at, can you all see my thing here? So if we've got CO2 in here in the atmosphere. We've got CO2, nitrous oxide, methane, and water vapor. So to get CO2 out of the atmosphere, we're talking about now, if we have yeah.
I do apologize for interrupting. It's just a little bit hard to see your board, I think.
Oh, yeah, it is actually. Can you see that?
That's better, yeah.
So methane, nitrous oxide, and water. So, having identified, we have to definitely stop fossil fuels, and we are working, like the whole planet, I think, is working about that, not successfully, but we have to stop, of course, like digging out if this is the soil and the fossil fuels were down here. We have to, of course, stop that we are filling that up. And of course, that CO2 went into the oceans and is acidifying the oceans as well, which is really important, for later. So how do we get the CO2 out of the atmosphere? And, politicians always try to get a technical solution, where they say, yeah, we can build some factories, but we are all scientists and we know, of course, the easiest is photosynthesis, right? So as soon, like I've got my green plant here, and as you all know, as soon as something is green and there's sunlight shining, this carbon will be sequestered. So if this is our tree and this is some grass, the CO2, of course, is made into C6 sugars. Yeah, you still with me? Yeah, you know all of that. It's basic carbon cycle. But then what happens is that this sugar is either made as lignin or as cellulose into a tree or into grass, but it's also pushed down, and this is our soil. It's pushed down into the soil, and in the soil, there is more carbon sequestered in the soil than above, than all in the atmosphere and all in biomass, like even of cows. I'm not an artist, as you can see, so that's our cow, and there might be a person. So we are all carbon chains, and carbon is sequestered in all of us. But what should be stored underneath the ground in the soil is bigger than what's above. Should be, shall I say. So now what happened is, we got rid of a lot of trees. So we are not, taking down so much carbon dioxide out of there anymore. But we also, through modern farming practices, we killed the soil. And the soil used to have about 15, 20, maybe 10, depending where you were, of organic matter carbon in it. Organic matter. Let's say about, conservatively 10, in really fertile ground, maybe 20%. And that's a lot of carbon sequestered. And how is it sequestered? In here, so the sugar gets pushed into the soil. And then, of course, the root mass is there, but then microbes. And microbes are extremely important, for fertility, and they create humus, and humus keeps water. And when we have water vapor as another problem of climate change and working as a greenhouse gas as well, the water should also be in the ground. So what happened now is that, like on my farm, where we used to spray a lot of Roundup and other chemicals, and this is happening worldwide, wherever industrial agriculture is, our organic matter is about from 10 down to below 1. 0.9, it was on my farm. Now, and those are the emissions, because when Roundup in particular is an antibiotic, so most people don't know what Roundup is or what it does. So Roundup is used on every bit of country that is used for crop production. As if it's not organic, people will use Roundup. Sometimes they use 2,4-D, which is Agent Orange, which is not nice either. And sometimes they use paraquat. Spraying with fungicides, you kill all the fungi in the soil. That is biomass. The earthworms, when you talk to farmers that were here in the olden days, they said that they had so many earthworms on the plow that every 50 meters they had to stop and take them off. And now you go onto any of this country, where we grow wheat, corn, soy, cotton, sunflowers. Next time you drive around the countryside, have a look, like when you see a country where, cropping is happening, which is here in Australia, from St. George down to, down to Melbourne, to Adelaide, Gunnedah, Moree, St. George, all of those. It's like there is nothing alive. It's all poisoned and spread out. So Roundup, let's stick with that, is a herbicide. So they, instead of using the plow nowadays, the farmers just drive over, spray, kill all the little weeds that are there, and then into that they can direct drill the next crop. And what it does to the soil, because it is not just a herbicide, it's also an antibiotic. And it kills the microbes in the soil and the fungi, because it's an antifungal agent as well. So the soils are dead. And if you ever bother to get out of your car and you go onto one of these fields and you try to dig into that, it's rock hard. Then you look when it's rained and the rain will sit on top. The water will not even go in here anymore. And then the sun comes and then, water vapor just comes up. And you all know when you go onto a paddock like that, onto a field, how hot it is. In the drought in 2019, the soil was 65 degrees hot. And of course, as biologists, as veterinarians, we know that temperatures above 42 degrees kill life, proteins denature, and then, life is... So all of these combinations together of intensive farming has got massive emissions of carbon dioxide, and that's where the 40% comes from. Yeah, so we have killed the fertility of the soil, humus is down, water does not get absorbed, plants don't get the nutrients, we don't get the nutrients, which is what I've got in my book, a lot about, and water runs off. And we get massive soil erosion also, because there is no biomass anymore to keep this. Also, those black paddocks, soil colored, when they're spread out, you all know when you're standing on that and that 65 degrees soil temperature, like you go onto one of these paddocks and you can't stay there for 2 minutes, because it's so hot, and what do you want to do? You want to go onto this paddock where there's grass and there's trees and you can stand above. So the cooling of vegetation is also taken out of the equation. So we don't get carbon absorption. We don't get carbon sequestration. The sugar that's produced, about 2/3 goes for the biomass of the plant, of the sugar producing photosynthesis, and 1/3 goes into the soil as sugar, feeding the microbes. And in 1 hectare, it's quite amazing. You have got about 2 elephants worth of biomass. Yeah, that is, and they're hungry. The elephants want to eat. The microbes need food, and they will multiply. You also know as vets, like in 20 minutes, you can have a bacteria from 1, 2, 8, 4, 8, 16, 32. 64, 128, they just can, when they get fed, they can multiply exponentially, which is what they do, which is what is so magic about there. But not if you are industrially farming and you expose it to the sun and you kill it, with not just Roundup, but with insecticides as well. So what can we do now to restore this, to make the soils and dead soils? I don't know how many of you are into regenerative agriculture, but dead soils are all over America, all in the Midwest, every farming country in America. I've just spent a month in Germany. Germany is not much better. The humus is dead, the soils are dead. And Australia, wherever there is cropping, the soils are dead too. You probably heard about the fish death in the Menindee lakes lately, 30 million fish. That was chemical runoff, overheating and chemical runoff and oxygen starvation. Again, probably agriculture. The dead zones in the Gulf of Mexico, where the Mississippi catches all the pesticides that are produced, on the country in the Midwest, all goes down the Mississippi, comes out in the Gulf of Mexico, and you have got huge dead zones and sometimes algae blooms, halfway to Africa. So agriculture does have a problem. They are our friends, and they produce food for all of us, and we got to eat something, and we are all in this together. And I don't want to point my finger at any one person, because they all have mortgages, farms are expensive, they're doing it tough, and they're my friends, I know so many here. But if there is a problem, which I think there is, then we have to all, try to find some solutions of how we can help, right? Now, carbon too much, water too much, and nitrous oxide. Actually, just quickly mentioning nitrous oxide, which is 300 times a strong greenhouse gas then CO2, it doesn't last that long. It lasts only about 8 years in the atmosphere, but it's still a really strong, and that comes massively, from nitrogen fertilizer, which again is used in industrial agriculture. Only about 20, 30, 40% of the nitrogen that farmers put on. And when your soil is dead and your nitrogen fixing bacteria are dead, you need to put it on. Like my friend Kim grows sheep, and she put an oat crop in for winter, and she said, Gundi, my soil is dead, and I know that, but I got to do something because I got to feed my sheep. And I said, sure, you have to, so she put urea on. And to make urea fertilizer, which is all over industrial agriculture, I mean, urea fertilizer, that produces this, nitrous oxide. Also from intensive farming in manure pits, there are natural nitrous oxide leakages all over the planet as well. But talking about farming, manure pits, intensive piggeries, that's where this comes from too. But also from growing, and now I'm saying it, vegetarian food, that is a massive problem. The massive problem also is because these bacteria in the soil, you remember the nitrogen fixing bacteria in the soil? Remember probably from uni that you had 70% of nitrogen in the air with a triple binding, which nobody can crack. Yeah, so industrial agriculture cracks it with a Haber-Bosch method in massive factories to produce urea. Yeah. So there is another climate culprit, in industrial agriculture right here. But what can crack this triple binding are the bacteria in the soil. But we killed them with modern agriculture practices. So therefore, my friend Kim has to go and spend her money on urea. The problem with urea is that it used to, apart from that it's massively energy incentive to make, it also kills the microbes in the ground again, which is a vicious cycle. So next time they need more. And recently in Africa, they had no urea anymore because of the international wars and the war in Ukraine. And I think it was China that put suddenly the price of urea up from $300 a ton to $1,300, within 1 month, they put that up, and farmers worldwide, so we can't afford that, so it's this chemical cycle, that got farmers so much into dependency so that they can't get off the treadmill. Now, coming back to getting CO2 from here back into the soil, because where else is it going to go? Like we can't catch it with technology and then put it through a factory and then put it down into some tunnels down there. So much in the atmosphere. The world is a big place. It's not possible. Of course, we have to use photosynthesis. So we have to grow more and more and more. We just have to grow stuff. We have to grow grass. We have to grow, and grass, by the way, is the fastest growing stuff, and bamboo. We have to grow trees. We have to just turn this off because it's we have to grow trees, anything, but then we have to store it. We have to store it in the ground. So we have to revive the soil. And if we can increase the organic matter in the soil from average of 1% nowadays to 10, 15%, then experts say we would absorb so much carbon out of the atmosphere that climate change would nearly be stopped, right? How do we do that? How do we push carbon down there? And this is where cattle come in. And just before I go into my beloved cattle, of course, we have got the ocean here that will, just by chemical equilibriums, will just fill this up. So if we put the carbon back into the soil and draw it out of the atmosphere, it will be filled up. And I did the maths once. I don't know if my math was right, but I got to 1,000 years of doing this and this and this to put it back into the soil before the oceans would stop filling the carbon dioxide up again. But we don't have 1,000 years. we are like at crunch point now. We might have we have nothing actually, like we don't even have 10 years because it is happening right now. Which is where we need to, a friend of mine, Walter Jenny, he's a climate scientist, he says we have to cool planet Earth. And for cooling it, like an evaporative air conditioning, so it's not, you can stop the nitrous oxide. We can put the water again, into the soil by humans will, did you ever, one of you had these little Woolworth soil sort of things, a few years ago, where you put, like probably 5 years ago, and you got them at Woolworth and you put a drop of water on and they went from this to this because they were so full of organic matter, and it was amazing to see. And that's what good humus should be. And it's just like, and that's how much water it's like in a hectare, it's like 2 Olympic swimming pools or something ridiculous, of storing water there, especially in a dry country like Australia, to put the water back into the soil and take it out of the atmosphere. In the atmosphere, it is like, we call them atmospheric rivers now, where we have so much water vapor there, and then it hits a cold front and then bang, we get a flood. So water vapor is the big thing that not many climate scientists ever talk about, but it's huge, the influence is huge. So what do we do? So the fastest way of increasing the organic matter and getting the soils back to life are cows. And with cows, I mean large ruminants that used to be in America. I don't know if any one of you has ever heard about Alan Savory and his holistic management, where he undeserted, so he revived thousands and thousands of hectares, of landscapes. So the principle of this is this: you have got grass, and grass grows faster and can absorb faster carbon than trees can. And it's not trees or grass, it's actually both. They live very well together. So when you've got a grass grow with a seed head at the top, it will stop growing. And you all know that it's like at the side of the road or in your garden, you let it grow and it becomes brown and dead. And when it's sitting there, it shades out everything down here and it will just get brown. When it's brown, it's not green. And so therefore it will not photosynthesize anymore. It will not absorb carbon. It will not push anything down into the ground. And occasionally a kangaroo might hop over and eat one of them. But what we need is, this happened in America really beautifully, when the big bison herd would go up and down the Midwest, so you had lots and lots of ruminants, in that case bison. Nowadays we have cows. And may I just add, we need to eat something, like we can't just let us all die, like 8 billion people. We need to eat something. So it's about what is the least detrimental to planet Earth and what could actually even benefit Mother Earth. So in my, so cattle have got a real place in there, where as a source, of course, we have to treat them really, really well, like needless to say, like we have to, I used to run cattle myself, and make their life as beautiful as possible. But even if we don't eat them, this is a principle. So when a cow herd comes along and we have got lots of long brown grass, they will come and they eat it. And if you've got a good farmer that does not overgraze, you will have about, let's say, about 15 centimeters, 12 centimeters of grass left. Everything on life just wants to reproduce, so once the seed head is here, the grass dies because it has reproduced. So it does not need to grow anymore. So it dies. But when a cow herd comes and eats it off, the grass will wake up, it will be green again, and it will start growing. And you know that principle from when in your garden, when you go and mow your lawn, and the lawn that is mowed is always green, but the ones that you don't gets really brown, right? So green means photosynthesis. So the cattle come and they poo here, here on the ground, and they pee here on the ground, and then they come with their hoofs and stomp it into the ground. And it's interesting that a cow has got less weight per centimeter than a sheep. So sheep are quite detrimental because they are too heavy, although they are not as heavy, but per inch or per centimeter square, they have got less weight, sheep have more weight than cattle. So cattle are not as bad with their feet, as we say. So they come and they trample this grass to the ground and have got microbes in it, and hopefully our soil is alive because we are in grasslands and not in paddocks that have been sprayed. And the microbes will take all of this litter that the cattle have trampled, and they will eat that. So the earthworms have food, the microbes have food, and they store that as humus, they store the water, and they can keep the carbon stable for very, very, very long time, like 1,000 years or more, we can have that there. So that's the principle. And then 3 days, I would move the cattle off, so I would have my cows in a paddock, small altogether, let's say 300 cows altogether in a very small area. And a lot of people just use an electric fence, have them there, strip, move them on 3 days max. You can do it with 1 day, but then you let it rest. And then you let, this all photosynthesize and grow again. And then you put the cattle back. And bison in America have done that through the millennia, and they've built up this beautiful, thick humus, that the Midwestern America had, superbly fertile. And then we humans come along, kill all the bison, and start farming, like growing wheat and crops. And then the Dust Bowl happened, and, and that soil there is now dead and sprayed 20, 30, 40 times a year. It's incredible, what that happens. And then we transport that wheat or the corn or the soy that we produce there, and then we transport it to California, where the cattle are sitting in feedlots, right? So it's a crazy system. And when you look at follow the money, wherever cattle in grasslands like I had, you sell your cow eventually, and you have a good life. But we don't make millions, and nobody can earn millions from us, cattle farmers, because we don't need that much, right? Because they do their own thing. But if you're a cropping person, you need urea, you need Roundup, you need 2,4-D and dicamba, fungicides, insecticides, and so forth. So the money that goes into cropping is huge. Inputs are humongous. The food that is grown is very bad. And the poisoning happening in those landscapes is even worse. And then, you sell it for good money, and hopefully you had a good season and you get a profit out of it. And the farmers that do that have a profit, have a good profit if they get it. Yeah. But the solution to climate change is to draw the carbon down and do that. So the cattle, I always do it like this, so cows, and the gardeners amongst you will know, when you have a rose or a geranium, and if they bloom, that you got to cut them, because if you don't, and the bloom is over, they will die, and they will not flower again. Like if you want to have your roses really flowering, you have to cut them, and then they do the same as the cows did to the grass. They stimulate growth. And I always do it like this, this is like the carbon from the air and pushed in, the grass grows, cows come, eat it, and it's pushed in, and that's your carbon pump going there and creating healthy grasslands. And when you have humus in here and grass, then you have got your small water cycle restored again. So that the water cycle, how much time have I got? 5 minutes. So then the water cycle can cool, because we need to cool, we can't just absorb this, then it can cool the atmosphere. Yeah. So methane. When in the Cattleback magazine last year, there was an article in June, if anybody wants to read it, June 22, where universities, I think Adelaide, Sydney and Melbourne, said we need to have cattle more in grassland. We have to have them more in feedlots. We have to feed them more antibiotics. We have to get them off planet Earth faster. And we need to feed them more growth hormones, because they produce more methane when they're in grasslands. And that might be true if you have a cow with a big rumen in there, and you put it back over her, and then you catch the burp, that you get CH4 out of there. But it's taken so much in isolation because it just does not even talk about the, so cattle in feedlots eat grain. Yeah. You are all veterinarians, they get acidosis. They have got tremendous problems with their rumen, liver abscesses, it's inhumane in my opinion as well. But apart from that, the grain that they get fed is grown on these big monocultures, with Roundup and other chemicals, that and genetically modified, and the seed monopoly of Monsanto, that is all happening in that space, killing Mother Earth on so many different levels. So that I think it's very isolated to say they burp out more, so they should be all in feedlots, yeah? Because cows, I always say it's not the cow, it's the how. Big herds of ruminants are nearly the only solution we have to putting carbon back into the ground through that mechanism that I tried to explain to you. I hope you understood that, how that works. The constant stimulation of growth, of getting carbon out. So I think it's a very, very dangerous thing to say that we need to feed cattle more grain and put them in feedlots, because if we grow any more grain and kill any more soil with chemical agriculture, because they are not fed organic grain, and they never will, that's not going to happen, so if we don't do that, if we increase, all properties like mine used to be, where the foxes, okay, they're not Australian, but mammals, flying foxes, birds, kangaroos, they can all live together on these beautiful grasslands. But you go to Moree, which is only about 100 kilometers from here, and there is eerie silence. There is not an insect inside. You can't hear it. Why do we have insect death? Why do we have species extinction? Agriculture has got, chemical agriculture has got so much to answer to, because the insecticides kill the insects. Yeah, the insects are the bottom of the food chain. They are either herbivores, so they eat our gum trees and our grasses, but they're the bottom of the food chain. If we kill them, the frogs, the snakes, the birds, nothing above them will be able to live. Birds from chemical agriculture, their shells are not hard anymore. So the bird population, I have got slides on there, I won't have time to show them, but bird population has declined. Insect population has declined by 60, 70, 75%, so that's all part of climate. So methane has been constant in the atmosphere at about 700 parts per billion. We have now got about 2,000, doesn't matter. We have got now heaps more methane. So it would say, easy to say, yeah, it's them. But we have actually on planet Earth decreased the amount of ruminants. They were everywhere. When you imagine in the tundra in Russia, like horses or whatever lived there, yaks in Mongolia, goats and yaks and sheep, and Africa, like wildebeest, they're all herbivores, right? In America, the bison, here in Australia, we had megafauna, we did a lot to them, but we used to have more ruminants on planet Earth than we have now. So they cannot be the reason, like 1 billion roundabout, then and now 700. But what happened in the 90s was that Boris Yeltsin started, extruding gas, and he didn't put the lids on properly. So that was the first surge. And then the second surge was when America under George Bush started fracking. Yeah. So now we blame the cows that have always been on planet Earth, and we blame them for methane, and we have to get rid of them. But yet, in my opinion, not just mine, like the whole regenerative agriculture has, it's talking about this, that cattle are actually the only life form that can fast, and I'm talking about to increase the organic matter in the soil through regenerative practices within 1, 2, or 3 years. You know, it's a massive amount that we can do in a very short time. This is what we need, you know, so we need to get in, especially to these semi-arid places, you know, where there is no carbon in the soil, you know, push the cattle through in big mobs. And in nature, you know, when the bison were in mid-America, you had the puma, you know, the big predators around, and they would push them together. The same in Africa. And this is where, you know, that concept comes from. And Alan Savory is a good man that developed this. And there's a great TED talk that I would advise everybody that's interested to have a look at, you know, how to reverse climate change and desertification. He made the big mistake. He thought, oh, we are overgrazing Africa. So he killed 40,000 elephants. And then he watched it, you know, what happened. And because he thought they are killing all the bush, there's too many of them. And then the reverse happened. You know, the country went backwards because it went to this long, you know, the grasses and the bushland, you know, went to this long vegetation, which then died. Nothing happened with it. It didn't hold water. It didn't pump carbon into the ground, and it just stayed there. So he developed then, and he spent the rest of his life developing this rotational grazing or mob grazing or strip grazing. You know, it's all the same principle of having lots of cows eat very quickly down to a certain amount of length, so that you still have got a lot of length left to photosynthesize, and then move the cattle on, and then wait, and then get them back. Yeah. So when you hear the argument, they're methane culprits, then now I hope you understand that is very much out of context. It's one little part of the equation. Yes. When cattle are burping out methane, and they do, you know, on grasslands, when we have a healthy ecosystem and we have the soil and the grass and the fog in the morning, and then the sunlight, if there is water, H2O, and sunlight splits up into hydroxyl molecules. And these hydroxyl molecules split the methane before it can even go anywhere. So Walter Jenny says it's about, you know, this system of fog in the morning in moist grasslands. They could burp out 100 times as much, and the methane would still be killed straight away. That will not happen in a feedlot because there is no grass. Yeah, so they might burp out less, but as I said, it's only part of the equation. Yeah, what happens with termites? You know, termite mounds have got their big CH4 methane emitter, but Christine Jones, you know, who is an amazing carbon scientist, you know, she developed all these liquid carbon pathways. She was one of the first. And she says there is so many, if the soil is alive, right? There's so many methanotrophic bacteria around a termite mound that the methane is actually less. So yes, they're spitting it out, but the methane eating bacteria around, the nature is beautiful, you know, like they are eating it. That is their food source so fast that the methane is actually less in the surroundings. And so that's very much the same principle, you know, as having that with the methane around, you know, the cattle in grasslands. So it's not as easy to say vegetarianism will save the planet. You know, it's the opposite. It's not the cow, it's the how. And I've got hundreds of books that I read about this. You know, there's hundreds of regenerative podcasts. You know, it's not my stuff, you know, that I made up. It's, you know, I got lots and lots of, you know, lots of discussions, lots of learning, you know, lots of books that I read that came up with this, you know. So grasslands, it is, we have to eat what's the least, you know, grass-fed, but you have to look at and organic, you know, like if you want to eat wheat or soy, then it's not even just the wheat. I mean, we're all, you know, so many people are overweight and diabetic, you know, so that's a different story. But if you do eat wheat, bear in mind that everything that is not organic is grown on paddocks that are sometimes sprayed up to 20 times a year. Your hummus that you're buying, and I've got that from farmers that are my friends that tell me these things. They are sprayed 20 times in one season when they grow it, with fungicides, killing the fungus in the soil, with insecticides, all to try to make these crops live, which are not resilient anymore because the soil is dead. So bear that in mind. Roundup as an antibiotic, we all, kills your gut microbiome. Wheat is now desiccated before it is harvested. Sunflowers are. I was driving around, in autumn here, the sunflower fields are black because they're sprayed out, as is the sorghum, as is the barley, so it is Roundup to dry it out. And then that is in your daily bread. But the damage that does to nature, and not just to climate, but also to climate, is just humongous, so where the hope is in all of this is that when we, I don't think the change will come from, we could all wait, and all of us, we can try to get the politicians to cross the line, stop fossil fuel, stop coal. It's too long. There is so massive financial input, or output from these big businesses. And I think this, you choose your food that you can do tomorrow. You can go to the shop tomorrow and you can say, okay, Gundi said, if I buy this egg, I pay more, and I realize that it's really tough, but that chicken, A, was happy, B, it was outside. Your egg has got more vitamin D in it. It's far more nutritious. The grain, though, came not from any of these poisoned paddocks. It came from an organic farm, if the egg is organic, right? So you got an organically grown grain. So that paddock where that grain grew for the chicken, the farmer doesn't get sick from the poisons, the river doesn't get poisoned, because all of those, go into the data sheets and have a look, they're all extremely toxic for aquatic life, going down, killing the reef. All of that is in your hand, to eat grass-fed, organic, either, go and eat vegetables, but eat them organic, eat wheat bread and eat organic, buy that organic egg, and feel really good about that. You can be part of the solution. And with every grass-fed meat that you're eating, you're pumping carbon in the soil, and that really works. One of my friends, Richard Makem here, he was put in as an outlier. He had about 19% organic matter in his soil. They said, no, that can't be true, but it is true, so yeah, I hope you got that. I completely went different, I haven't got my slides, but I hope you got that, my scribble. And I'm here. You can buy my book on Amazon,
Thanks.
And you can just ring me, I'm here, I'm in the clinic, I'm available.
No, look, and thank you. I feel like your discussion has already started the questions. They're starting to come in, which is wonderful. I love that you ended on a message of hope, because we really do have the solutions, and it's a matter of, engaging with those. Yes, we can choose our food, we can make informed choices, but there's also a place very much for, advocating for change, and, knowing that the cattle aren't the culprits that we think they are. We do need to turn to keeping fossil fuels in the ground. So Susan has asked, why organic cattle? What's wrong with animal treatments? Do you have a response to that?
You mean animal treatments as in treatment against diseases, or?
Susan, do you feel free to come off mute if you want to ask your question or provide any more details?
Yes, I'm talking about anthelmintics in particular, but any of those treatments, antibiotics when they're required, etc., etc. I'm not talking about routine antibiotics. I'm talking about
Look, you know, like when I say organic, I mean, organic is such a term, you know, and yes, you know, you've got the, you know, AFO, Australian Organics, you know, or NASA that give their standards, and a lot of organic farms might not be even that organic, you know. So I mean it now in the purest sense, you know, do what you can, you know, like just feed that is grown without chemicals. When I had my cattle, you know, like cows are actually quite good anyway, you know, with anthelmintics. Yes, my son is hungry. It's like pasta. Yes, it's organic pasta. Yeah, so I'll be there 10 minutes. It was Julian. So yeah, anthelmintics, sometimes you need them, you know, like always try to find another way, you know, like I never had to actually worm my cattle, you know, because they were out in grasslands. And when I weaned them, and they might have had ostatagia, I kept an eye on them, and they actually did never. Different when you have got sheep, you know, sheep are so, as you know, Haemonchus is just such a tricky one, you know. So I think the regenerative label is discussing this, you know, what are we allowing and what are we not allowing, you know, and they will, that label is not there yet, you know, you can't buy regenerative food yet, although Rachel Ward made a beautiful movie, you know, Rachel's Farm. If you watch it, it's really entertaining and really good. And
I'm seeing it on Tuesday.
Yeah, it's good, isn't it? Yeah. And there's at the end there is a, you know, a website, you know, where you can find these regenerative farms. You know, regenerative farming is not a label yet, you know, so it doesn't have any rules yet, you know, so nobody will say this is, you know, not allowed or this is allowed. And antibiotics, you know, like, yeah, you know, like antibiotics in feedlots are at subtherapeutic levels, you know, of virginiamycin and lasalocid to counteract the acidosis, you know. So yeah, difficult in, yeah, and those cattle, you know, if you need to treat something, they're just taken out of the system, you know, they can't be sold as organic.
Thanks, Gundi. Sounds like that was Susan, you might have got your response there. James has asked a question. Do you think we can achieve production of enough volume of food to feed the world population through an organic or regenerative approach, which is often framed as creating a reduction in food supply? Good question.
Yeah, you know, so there are interesting statistics, you know, like that, that yes, we can, you know, like absolutely, you know. And the fun stuff is, you know, once you start working with soil biology, you actually can, I think it's unsustainable if we don't. But when you get your soil healthy and you get the bacteria and the microbes and the nematodes and the earthworms work for you, your yields can actually double or triple. You know, I'm working with a friend of mine in Germany. He works with a lot of farmers and a lot of vineyards and a lot of vegetable growers, you know, and their yields are double or triple the amount. It's a bit like treating a horse with yellow lotion, you know, that has got a wound. And then you stop using yellow lotion, you start using honey, and suddenly you see, oh my God, you know, this is what healing can be. And, you know, you can get healthier crops and more of them, you know, when you change your farming systems, you know, to bacteria again, you know. Plus, you know, I just have to mention this because I can't help myself. Did you know that all essential amino acids and all B vitamins and alkaloids, they're only made by bacteria in the soil? You know, so if you kill them to grow wheat, for example, to feed the masses, yeah, you're giving them such a dead carbohydrate to eat that is lacking in all the B vitamins. And those sort of things you see in the population, you know, as an avalanche of sickness, you know, of diabetes and cancers and blah, blah, blah. You know, I won't go into that, you know, like, but yes, you know, and a lot of food production is just so commercial, you know, like I quite often say, I don't see many farmers that I know and that I like, you know, that are actually growing food to grow food. You know, they are there on their farm and they grow food to pay the next bill, you know, of the banking system, you know. So there is that change, hopefully will be supported, you know, it has to be supported by banks, you know, by the consumer, you know, and by agriculture. We can do this, we can turn this around like that. It's not that hard, you know. We can grow bacteria, you know. I'm doing it here at my house, you know. I'm growing anaerobe bacteria compost teas, you know. So there's heaps that you can really get your yields increased rather than decreased.
Thanks so much, Gundi. I'm very conscious of the time. So thank you so much. I will just make a last comment, which is acknowledging that Helen has pointed out that issues around animal treatment can be very complex, and a blanket ban, of course, on all chemical treatments can have adverse effects. So thank you so much for your time this evening. I'm pretty sure that we have a good understanding of soil, of ruminants, of how cattle are not completely to blame. I will just point out that we took a delegation of the board and some supporters down to Canberra last week to just talk with MPs and the government and support a number of Northern Territory doctors and parents to talk about the dangers of fracking. And certainly that is a huge impact on the emissions of methane, as you pointed out, particularly as we saw in the US and in Russia. And we're going to keep you up to date with that issue, because I think it's a really important one, that we try and prevent this development in the Northern Territory, in the Beetaloo Basin and in the Middle Arm Harbour of Darwin. We really need to stop that from going ahead. So thank you. This has been recorded. Feel free to share widely. And thank you again to our volunteers. If you would, we can't do what we do without our volunteer support, nor without gifts from our supporters. So thank you so much. Stay up to date. We will be running another webinar. Claire, I want to say the 26th of September. Is that correct?
It is the Tuesday, 26th of September at 7 to 8 p.m. Correct.
Wonderful. And we'll be hearing from Feed for Thought, who are producing insect-based pet food. So I think this could be an interesting one, and the impact on or reducing the impact of pet food on climate. Gundi, thank you again so much. Please all go and enjoy your evening, and thanks for joining us tonight.
Thanks everybody for listening. Bye-bye.
Bye.